Swayam Prabha. Digital India. Educated India.
Welcome to week 3 lecture 2. So, this topic deals about universal design with a specific focus on vision impaired people. Now, we have discussed generally the general guidelines about universal design and inclusive planning, but this particular session will focus on or will highlight the requirement of people with vision impairment. Now, here we have considered two categories, like people with impaired vision, that is who do not have any sense of light. So, for them it is all about touch, and people with low vision, that is who have some sense of light, and they can maybe they have other problems like blurred vision or maybe advanced cataract due to age, or due to some kind of brain injury, skewed vision, or we will discuss this in next few slides. So, these are the two major categories which we will be talking about. Now, for people who are blind, it is mainly, everything is tactile. So, every communication has to be either tactile, or auditory. But for both people who have no sense of light and who have partial sense of light, what is important, and probably this is something which is common with the people with locomotor disability also. Like as I said that this is very specific to this lecture, is very specific to people with vision impairment, but this one, an unobstructed path of vision, is common to the people with locomotor disability. But only thing that is important is that there should not be any protrusion in the free movement path, because we have to understand how a person who is walking with a cane, who is vision impaired, how they are feeling the space, how they read the space. They are using this cane to feel the space, and many a time they touch the ground surface to feel what is coming ahead. So, if any kind of obstruction, if they are located near the ground, they can identify. But if something is protruding out like this at an upper level, they are most dangerous, because they will not be able to sense that. As a result, there has to be some kind of protrusion or some kind of restriction on the protrusion. But for people who have no sense, absolutely no sense of light, it is the signage will be all about tactility. So, it can be braille, or it can be many a time nowadays we are using embossed text, that is text which is raising above the background, so that they can feel it and understand. TGSI is there, and we have talked a lot about TGSI, so I am not repeating that. So, what is essential is that the proper placement or the laying of TGSI, we are aware of the directional tiles and hazardous tiles, but what is important for people with vision impairment is to guide them properly, and the most challenging thing in this case is how to negotiate the corners or how to negotiate the change in direction. Say for example, when someone is taking an L turn, or someone is taking is negotiating a T junction or a cross. So, it can be something as simple as that, something like this, but it is preferred that you have a 2 layers of hazardous tile for better comprehension, for easy understanding. because just try to imagine when someone is touching the ground with the help of the cane, it is difficult to exactly pinpoint. So they might be slightly moving the cane in a way, so that if you give a wider coverage of these hazardous tiles, it is always better. Now there should not be any compromise with the laying of this TGSI, and this should actually lead to every point of interest, what we call POI. So every point of interest or everywhere a visitor might be required to go should be connected with the TGSI, and when the point has arrived, there should be it should be indicated by a row of or a layer of hazardous tiles or the warning tiles indicating the end. So anything, I mean the big another important point is, whenever there is a level change, there should be TGSI. Whenever there is a initiation of a pathway or initiation of a ramp, maybe a ramp starts or a pathway starts, so and ends of course. So these should be demarcated, this should be identified by hazardous tiles. So any beginning or end of a route, be it at one level or be it at or be their level changes, need to be identified or need to be marked by hazardous tiles. So in case there be some such obstruction in between, the tile should be laid in a way so that people can avoid that. Well, this is just I mean not a major obstruction, but there could have been a lamp post or could have been a tree or something like that. So these laying of tiles like this is very important. And needless to say that it should not be unnecessarily elaborated, the layout of TGSI. It should follow the minimum path. The minimum path of travel should be the guideline or should be the guiding factor for laying of TGSI. Another important way to tell people about or give people a directional sense is to have some indication on the handrail. Like if people are moving along this place, and this kind of arrows would tell about the direction of movement. So these are an advancement over the physical layout, that is when we have talked about the RIAs, that is the auditory signals, that is remote infrared audible signals or signage system. So this relies on the infrared communication system, and it is a company which developed this brand under the brand name of Talking Signs, which they pioneered the implementation of infrared communication system way back in 1993. Again, Mitsubishi Precision Company, they joined hand, and till then the research and development has happened, and today we have many advanced technologies in this field, that is where we have this talking signs. So what the mechanism is that there are the auditory, the signals are to be captured. So as we can see that these are the infrared transmitters. Infrared transmitters are planted in different points. Like earlier what we were doing, we were having this kind of TGSI which probably would lead you to all these spaces. But here what we are having these infrared transmitters which will tell exactly which facility is where, because TGSI will not tell that which direction, if you move in which direction, where do you reach. If you want to reach the elevator or if you want to reach the registration desk, whether you should go left or whether you should go straight, that TGSI will not tell. But the infrared transmitters, if planted properly, they will tell that. So this is this kind of a receive. So it has got two components. One is a receiver, where it can generally accompanied by a neck strap, with speakers and on and off buttons and the sensors. So, what happens that when the infrared beam transmits the message embedded in the sign, so these are the talking signs to the handheld receiver from where which is heard through the receiver speaker. Simple mechanism, but I think it is very very useful for independent navigation. So, this is the handheld part, receiver, and then this is the transmitter. So, so this kind of a transmitter say above a doorway will give it an identity that, well, this is this, so someone can follow it. So, what is the role of the architect and the designer? To plant these transmitters in strategic location, and something which will be just to be aware of this. I basically to be aware of this mechanism, and specify those transmitters which maybe are used by majority of the people, which have a good reputation in the market. So that I think if you remember in the universal design principles, we have discussed that it should be compatible with the various devices. So, this is what it should, the compatibility is important. So, this is how it shows the, it can be the transmitter which is there at the test in front of the elevator. It is mounted in a box, usually mounted at an approximately 7 feet above the floor, so that it does not interfere with the common people movement. It has got ranges. Now, it gives signal from it has got a transmission cone. So, it is not from every, so when someone enters there, they can pick up that signal. I have mentioned these many of these very interesting journal paper on this. It is the link is given here along with the DOI. So, you can visit this. So, this is something ideally what should happen, that every transmitter should say that what is available where. So, refreshment, coffee, newspaper, magazine. So, this is exactly the exit to the 4th street. So, this is how people are, the person who is carrying this, he is receiving this information. Now, if we come to the next part, that is the design for people with low vision. So, here what we are having, these are the different kinds of visual acuity problems. If this is normal vision, loss of central vision, this generally happen due to muscular degeneration, advanced cataract which happens with age or with lack of nutrition and all. Then sometimes due to some kind of a head injury or cerebral stroke, there is a 1/2 of the field of vision get lost. So, what is the implication of all this? You require, say that means that someone who has a blurred vision due to advanced cataract would probably only react to very stark contrast. Like if there is a white door on a white background, cannot understand that. But if there is a brown door on a white background, or a glass door with a contrasting yellow frame or an orange frame on a white against a white background, they can probably understand that. If there is someone is having this kind of a partial vision, like loss of central vision, or this 1/2 is lost, then cannot react to small text, cannot understand. If the signboard is too small or located at an insignificant position in the environment. So, we need to place the signage or have the proper have the objects which are required to be viewed in a place, so that they are easily visible at maybe at the center. So, these are some visual acuity problems, these and which are related to the interior space design. So, let us discuss this one by one. First one is the contrast sensitivity. So, many a time people are not able to distinguish an object which has got a poor contrast with the background. Now, what happens, people who do not have a very good 3-dimensional perception, So, if a white object is placed on a white background, they will not be they will not be able to appreciate the depth of it. So, cannot understand that there is something there, so they may go and hit it. So, there is a, I mean when, so where when we are designing the spaces, particularly public spaces, it is, though we have a what do I say, passion, many of the architects, we do have a passion for monochromatic rendering, but yes, that might be a problem for some people. So, this is just for the sake of awareness, because I mean this happens due to the lack of ability to perceive an object in its 3D entity, in its 3D form. So, now here also, I mean if there is a lack of contrast sensitivity, this where the horizontal surface is ending and the vertical surface is beginning, it is difficult to understand. So, that is why, I mean in this kind of, particularly this is a hospital interior, so this kind of the of therapy spaces, generally they are marked by these deep colors or the dark contrast colors in the at the junctions. Also, as you can see, the handrails or the grab bars are painted in contrast color. The edge of the furniture are painted in contrast color, so that people can identify it. Similarly, I was talking, that is the door, say a glass door, people might not be able to understand that, they may get confused that whether it is a glass door or it is just an opening. So, that is why these dark blue or bright blue frames are given. The toilet doors are in contrast, the toilet seat cover has been given a contrast. So, when someone is coming from the parking, just see the color, the elevator it's in orange and dark orange contrast, it shows out. Against the orange, a black grab bar, the lift wall where the panel is there, it has been given a contrast, so that people can easily find it and locate it. The seating has a contrast. Same can be extended to the external spaces as well. Like now this is a sensory park. So, a sensory park, like as you can see here, the texture is also different. So, a sensory park is somewhere where people who are low vision as well as impaired vision, they can move and they can feel different texture. They can feel the concrete, they can feel the pebbles, they can feel the grass, they can feel the sand. So, and that feeling, that tactile feeling has been enhanced by the different colors also, so that you cater to both the groups. There is something called disability glare, like when there is a excessive light, excessive bright light, when there is some source of bright light within a person's field of vision, which creates excessive glare so that they cannot see. Also, there is something called a discomfort glare. Now discomfort glare is generally the light which originates from a high luminance source, which is a point light generally. Bright lights close to line of sight or bright sources against a bright background. So, these are some kind of the glare. Now, disability glare and the discomfort glare are similar, but mainly I mean the difference is that discomfort glare is when, I mean there is a sense of irritation or pain from high luminance sources. Then we have the source glare, like when we use smaller lamps and fixtures to increase the efficiency, but the higher lumen output from the point sources can create glare, and as you see that this has been the reflection in this, which gives a sense of illusion, creates an illusion. Similarly, it has happened here where there is a reflective glare, in which someone who is walking here, I mean when sees this, it gives some kind of a 3D perception. It is misleading elevation change which disguise the path of travel. So, this kind of so we have to be very careful about the choice of material in the public places, particularly in the interior. Now, so differential lighting in the transition zone. we know that when we move out from a dark area to a bright area or otherwise, I mean there is always a, I mean our eyes take time to adjust, our pupils take time to adjust. So when that is happening, particularly who have a vision problem, it is more problematic from them and they get incapacitated for a while. Shadows. We architects rely a lot on shadows, we play a lot with shadows, we have these projected masses so that they can create a shadow and we get a good elevation. So we cannot, definitely would not want to compromise on that and have flat elevations, but let us understand also that shadows on the building facade may look good, but when these shadows, when certain elements cast shadow on the movement path or on the major public movement path, they might be disabling. They create a, I mean then navigation might be challenging because they appear as objects, they appear as a pseudo change in elevation. They sometimes, I mean these things, they appear as a freestanding objects. Now these are the smaller light sources. When these are point sources, they when fall on the wall, they sometimes create a scalloped kind of effect on surfaces. So as a result, it is not possible to understand or find out the obstacles. And this is, yes, I discussed this, that is the monochromatic fashion, like it is difficult to identify, particularly for a partially sighted person, to see an obstacle protruding from the wall if it is not of contrasting color. It is, we discussed this earlier, that is the contrast sensitivity, but it is similar to that, which is also known as the monochromatic fashion. Yes. Now floor finishes, I think we can see that. So this beautifully designed staircase, red, maybe some kind of stone, and what we have is the risers are white or gray color. Then it has got a black border and it has got a red thread. Now when someone comes there at the last one, there is going to be a false stepping, because I mean they again this 3D perception is not very strong. So there was actually no need of getting this putting this additional red strip. It should have stopped here. It should have stopped with this vertical surface and not continued here, because it is definitely giving a perception of an additional step. So there will be false stepping. Similar thing has happened here. I mean if you look at it from this side, from this angle, it appears there are 3 levels. So again there will be some kind of a false stepping and lack of balance. A floor finish like this kind of distracting patterns is absolutely not recommended for a public area, because it again creates an illusion, it creates confusions, appear like steps and contours. So a pseudo 3D effect. So the takeaways, the critical elements are to be made larger and ensure that they have high luminance, so that people with low vision can identify them. Contrast is important. Task lighting is very crucial, because it focuses on the particular task area and does not clear any kind of disability or discomfort glare. It is important to have if we want to put a signage or something like that, it is important to have a uniform light over that. If a signboard is partially lit, then it creates again some kind of illusion. And for any outdoor spaces, there should be the the windows and the doors or the other openings should be glare controlled to minimize any kind of detrimental effect due to the contrasting light. We have already discussed signage in detail. But just to but from this visual, the vision problem point of view, so these are some of the prescribed high contrasting colors internationally accepted and some poor low contrasting colors. It kind of demonstrates the readability at a distance, with number 1 being the most legible one and number 18 and is in the decreasing order of legibility. This is the color contrast visibility chart. The which combinations have got the best and which combinations have got fair and poor. So, if we see that all these combinations which are like blue and white, that is the combination which we use for international sign of international symbol of disability. This green and white combination, many of our road signs and highway signs, they have this green and white combination. We have this yellow and black, like where we have these mountain roads and which kind of bend. So the bends are marked by yellow and black bollards. We have the traditional, we have the zebra crossing as black and white. So what we see that all these are very standard accepted contrast and prescribed for different kinds of signage, and we have examples of fair and poor contrast. To end with showing an example of the Mexico School for the Blind and Visually Impaired. So, the design goal was that, so it was a school for the blind, so it had two purposes. One is it had to be universally designed, so that people, so that children can be comfortable and can use the space, and also there has to be, they need to be treated. They need to be treated to and give, they need to be trained. They need to be trained so that they can face the external world better. It had good acoustic because they have to appreciate and start recognizing different sound. So if you want to make them aware the sound of a maybe vehicle horn, so they need to recognize that, they need to understand that, they need to hear that very clearly. That's why good acoustic is important. So also they rely a lot on sound because they cannot see. So the overall BGNL, the background noise level, need to be less so that these are heard properly. And also the building was a simple building with clear wayfinding and orientation to help them, and there were very important the sensory landmarking. We talk about landmarks in urban design, we talk about landmarks in environmental psychology, but these are sensory landmarks. So this was the building, a single story building with a clear entry. This was the vehicular entry, the bus stop, and here this was the therapy areas, the playground was there, a garden was there, and a bike track was there. So this is the playground. As you can see that different materials are used. The movement path has got an entirely different material from the play zone, because they were getting used to, or they were getting introduced to the various texture, that if this is grass, that means they would know this is a safe area, it is a non-vehicular area. So wherever they find grass outside or this kind of a feeling out in the external environment, they would know this is safe. But maybe wherever they feel something like this or this kind of a concrete, they would know that there are possibilities of this, there can be a vehicle, there can be vehicles flying, because this is a movement road, this is a corridor. So this was a classroom cluster they had, in which these were the classrooms, and there were something called focus rooms, if you can see. So focus rooms kind of helped them to or to train them for performing their basic daily activities like changing, dressing, cleaning, all these. This is very interesting. Now, this is a classroom interior. So, what we see that they have got very demarcated activity zones, and each classroom includes a sensory landmark, like this is the water. Imagine someone who has never seen river, never seen an ocean, never seen what are the ripples in the water look like. So they can feel that, they can feel this and see that what exactly is meant by waves. They can feel a wave. They can understand how if someone stand by the side of the sea, how do the waves come. So that's how they were made to feel this. And also, as you can see, the active zone and the passive zone have got different marking. This is smoother and this is rough. This is the tree. I mean, if when we were child, I think we all of us have drawn tree like this. I mean, we used to draw some kind of a trunk and then this kind of foliage like this. So what so here also, but these people have never seen what a tree look like or what the canopy of the tree looks like. But when they touch this, they can understand how does a canopy look like. So these are the sensory landmarks. They had a therapy corridor. So now this therapy corridor, so they were made to walk and have different kind of experience. Now this therapy corridor lead to these classrooms, and in every classroom there was a particular type of this, what I said, this tactile landmark. So this was the landmark. So which helped, so this had different design or different feeling, different tactile design. So by feeling this, they could identify which one is their classroom. So the therapy corridor led to a transition zone. So this is the transition zone. So now it had different kind of wall finish. So when they were moving out from this transition zone, what would happen? They would gradually move from a smooth surface to a rough surface. So they would know that what an interior finish is and what an exterior finish is, so that they know in the real world what happens, how things are designed. Another example with bright colors, sensory elements, and this is a draft from an embossing printer for an architect. Some of the references, papers, this DOIs are marked there. You can go through this, and also this maybe you can visit this site. Thank you.